What's up, everybody? Welcome back to GSI Guy. We're going to be talking about some 767 hydraulic systems today. I know everybody's very excited, but I've decided to change it up a little bit. So what I've done the last couple videos with like the electrics and the IRS, I've actually had inside the airplane on X-Plane showing kind of what you do and the different switches and that kind of stuff. I decided to change it a little bit today. So I created a short PowerPoint presentation, very short. It's only 12 slides. I know you guys don't like death by PowerPoint, I don't either. But it is easier for me to go through and explain this way and then kind of show in the airplane what to do. So really it's just going to be like an overview of the hydraulic system. Again, all of this stuff is kind of like high level information. It's not stuff that gets in the weeds. It's not stuff that, you know, goes into too much detail. But essentially, we're just going to talk about the different systems, some of the things that are on them, some of the things that are important. Again, everything is subject to your company's training. Has nothing to do with any training program as far as what I'm doing today. Again, everything I do because I really enjoy the 767. I like teaching, and this is just something I kind of do for fun, ironically enough. So, like I said, we're going to start off with the hydraulic systems. If you have any questions, you can always put them in the comments. You can send me an email. The email's attached there in the description. You can always do that, and then yeah. We can always have I always love having good conversations about this kind of stuff. I like talking about aircraft systems. I like learning about aircraft systems. I'm just weird like that. Alright, so anyway, now we've got that out of the way. Let's go ahead and get into it. So, like I said, we're going to start with the hydraulic systems. We're going to start with some controls and indicators. Some things that you need to look for when it comes to how the system works. So the first thing we're going to do is we're going to look at the actual overhead panel, right? So on the overhead panel we have our hydraulic panel that's located on there. It'll be located on the left side towards the forward end, so towards the bottom of the overhead panel. As far as I know, every company is pretty much the same in that regard. There are some other panels that we'll talk about in other systems that they move around. They're not always in the exact same spot every time. This one is one that's going to be in the same spot every time because it would kind of be a pain for maintenance to be able to, you know, move it and that kind of stuff. Alright, so real quick, just to kind of go light for light, we're going to start at the top and we'll go from the top and we'll work our way down. So the first ones, these seem pretty self-explanatory, right? System pressure. Well, system pressure is low system pressure, meaning the pressure in the entire system is low, whether that be the left, center, or right. Next is our quantity light. Not all airplanes have this light. Some planes have an RSVR, or reservoir light. They both mean the same thing. It doesn't matter. It's just how it was ordered. So basically what this light's telling me is I have 50% quantity left in the reservoir for that particular hydraulic system. And we'll talk a little bit more about that later. Now we have our primary pumps. These are our primary pump switches. So these are actual alternate action switches. So in case you forgot, alternate action switch is one when you push it, it actually goes into a new position. And then we have what's called momentary action. Momentary action is where it just goes in, it makes a connection, and then comes back to where it was. So all the switches on this panel, they're either switches, like rotating switches down at the bottom, or they are actual alternate action switches that we push for the primary hydraulics. So I've got engine driven on the left and right side for my primary, and in the center it's electrical. If you ever have any question on what drives what, read the panel. Boeing did a very good job of making this, I don't want to say dummy proof, pilot proof, maybe, but then some of you will think I'm calling you a dummy. But if we look at this, it's engine for the left and right, it says it right on it, and then electric for the centers. There's also press lights that are located on there. We'll talk about those in a little bit. Just know those are low pressure lights is all those are. These, again, trying to make it about as dummy proof as possible, putting overheat on here. Well, anybody want to take a guess what that is? Yeah, you got it. It's overheat. So that's an actual temperature of the fluid coming out of the pump. When the pump produces a fluid temperature above a certain point, you don't need to know the number because it's not important. You can't see it. Then the overheat light comes on, and then you have to deal with it from there. After that, we have pressure lights down here on what are called our demand pumps. So now we have, instead of engine-driven pumps on the left and right as our primary, we have electric-driven pumps on the left and right demands. And then our center is air. Again, the panel tells you what runs it. It doesn't tell you what specifically runs it. It just tells you that it's either electric or it's air. Pressure lights, again, low pressure. We'll talk about some differences between that and the primaries, though, here in just a minute. So don't get too wrapped around that. Overheat, again, it's an overheat in the pump or an overheat in the fluid. Basically, the fluid coming out of the pump is too hot, and it throws an overheat, telling you something's going wrong. Yeah, we'll talk more about that overheat here in a minute as well. All right, so as we come down here, these are the rotating switches that actually turn our demands on and off, or put them in auto for that matter. So auto, that's self-explanatory. It automatically turns itself on, turns itself off. In the off position, it's off, and in the on position, it's on. It's running. So auto is the only one that makes it turn on and off by itself, which again we'll talk about in a slide or two. Another thing that's important to note is the actual location of this, right? So we have our location right here. So it's down here in the bottom left-hand corner. Again, everything's kind of turned off in this particular picture, so I wouldn't worry too much about it. But there is one other thing that is pretty important when it comes to our hydraulics, and that's going to be located right here. I had this open, so it doesn't do it any justice, but underneath here, it's called the ram air turbine, or the ram air turbine, I guess, depending on your accent or how you talk. But the ram air turbine is located underneath that particular switch. It looks something like this. Hopefully the lights aren't on it, because if the lights are on it, something bad's happened. Either you've pressed something you shouldn't press, or you have some sort of failure that we'll talk about. But this is the next biggest thing that comes into your hydraulics. And this is because this is what allows you to be able to fly the airplane in the case of a dual engine failure. The reason I said that, I hope the lights aren't on, I always called this a resume switch. So basically, if you were to hit this switch on the ground, you'd have to update your resume because you're probably looking for a new job. That may not be the case. It's more of a metaphor than anything. Just don't touch the switch when you're not supposed to. That's the biggest thing. What you can't tell is it is a guarded switch, so the guard's down right here, and then it's up right here, and that's how I was able to get those lights to come on. So anyway, when we talk about the ram air turbine, okay, so we talk about what powers it, and then what does it power, and I'll show you that here in just a sec. So here, where does the rat get its power? Alright, so if you watch the electrical video that I'm going to put a card to up here above me, and it'll be attached to a playlist that'll have all these systems in it, and you can go in and look at the electrical one. It's about 40 minutes of me talking about electrical systems, and I'm sure people just love listening to that. But in there, it talks about an acronym. At least I think I did. If not, I'm going to give it to you now. The acronym is FRIC, F-R-I-C. And that's gonna stand for what's on our hot battery bus. So, look at that, I just gave away the answer. So the hot battery bus has on it fire protection, it has the RAT, it has an IRS, and it's got a clock. Those are the things on the hot battery bus that we tend to care about and that we tend to teach, at certain airlines. But that means the RAT gets its power from the hot battery bus. So what does this mean? That means that switch is powered at all times, and it can drop the rat at all times, even if you hit the switch accidentally. Again, not something you want to do, but something that could happen, I guess, if you're going through a pretty quick pre-flight or if you're just not paying attention. Okay, so the rat automatically deploys in flight during certain things. And I already kind of mentioned it. I said dual engine failure. So dual engine failure is going to be both engines below 50% N2. And you'll realize as we go through later on different systems, when we talk about, you know, the engines and the power plants and that kind of stuff, that 50% N2 is going to be a big thing. That's going to be a big number that we're going to go back to a lot. But that's what's going to determine a dual engine failure, is when both engines are below 50% N2. So in that particular case, if I'm flying and both engines drop below 50% N2, what should happen is the rat should automatically deploy. And when it does that, this light right here comes on that says unlocked. Okay, to tell you that the rat has actually deployed out on the bottom part of the airplane. Once this light here comes on, this green pressure light, that is when we have good pressure. This is the only pressure light on the entire overhead panel that is what's considered a good pressure light, because, well, we need the pressure from the rat to be able to do this. So there's an airspeed associated with that, because again, we're supposed to be in flight when this happens. So for us to be able to get enough airspeed to be able to get this green pressure light, we need at least 130 knots. So 130 knots is the number that comes along with that green pressure light. Now, I said it auto deploys, right? There's an airspeed that arms it for this auto deployment. You can be on the ground and hit this airspeed, which you're going to be on the ground and when you hit this airspeed, but we're looking at 80 knots. So at 80 knots, there's a signal that goes to the rat and says, okay, I'm ready for auto deployment. There's one caveat to it though. So, does it deploy on the ground? Well, let's think about this. You're taxiing in, you get to your spot, shut the engines down. So you pull the thrust levers into the cutoff or the idle position, and then you go cut off on your fuel selectors. Engine shut down. Does the rat come out? No. That's because it will not deploy on the ground. It's inhibited on the ground. There's a switch on the main gear. It's your tilt switch, so your air-ground sensing switch that tells it, no, I'm on the ground, I'm not going to automatically deploy because, well, I'm on the ground. But again, you know, you still have to be going faster than 80 knots anyway for it to be armed for auto deployment. Outside of that, you can push the button and you can always lower it. Doesn't matter if you're on the ground, in flight, doesn't matter what you're doing. Alright, so one thing that I am noticing now that I forgot to put in here, but it's in a schematic that's in a couple slides. What does the rat provide me as far as hydraulic pressure? There are people, when they come from other types of airplanes, I think Embraer, the ERJ 175 does this, and there's others that have rats that will actually provide electrical. This rat doesn't. It doesn't give you any type of electrical. It only gives you hydraulic. Not only does it only give you hydraulic, but it only gives you hydraulic on the center hydraulic system, and it's only to primary flight controls. And I have a picture that I'll show you that hopefully will kind of make that all tie in. But I want you to hear that again. Only hydraulic system pressure, only to the center, and only for flight controls. Okay? That means you don't get the additional stuff that you have on the center system. Now, if you've never seen the rat deployed, this amazingly is pictures from X-Plane, and then I have two pictures of the actual rat on an airplane that's deployed. But for this one, I didn't think X-Plane would actually show this, but it's kind of cool. So I pushed the switch and doom, it came out just like it's supposed to, because it's on the hot battery bus, if you remember. But if we look here, this is the right side of the airplane, right? So this is the right side of the airplane. showing that it's deployed here on the right side of the airplane. This is a zoomed in picture of it, which is pretty accurate. It's located right there. This is looking forward on the airplane. So if we're looking forward, this is what you see, but this is only an X-plane. So if you're one of those people like me where you do flight sim because, well, I don't have, a pilot's license, or I don't have a pilot job where I get to go out and fly these things all the time, so I have to do things like use X-plane. Please understand, this is not how it looks on the actual airplane, and I'll show you why. This is what it looks like on the actual airplane. It does look like a blade. It does look like it would be painful if I was standing underneath it. And then, of course, here you can see there's no red markings, there's no red box to say don't stand underneath here. We're on the actual airplane. It does have those red markings, and it's got this big red box here on this panel that says don't stand underneath here, because that would be bad. Now, the difference is that's looking forward on that second picture. So on the left-hand side, that's looking from the right side to the left side of the airplane, so you can see that it faces forward. And then you can see that the door actually opens the opposite direction that X-plane shows. Not that it's a huge deal because it's X-plane, it's a video game, it's not really anything that's pertinent to anything. I was just trying to show you the difference of what might be on a flight sim versus what's actually on a 767. Now again, this gives you primary flight controls on the center hydraulic system. Okay, it's not very big. I don't know if you noticed that. It's not very big. And when I say that, I mean it's probably, I don't know the dimension of it, per se, but it's less than 2 feet, or right around 2 feet. It's not very big. So when you think about trying to run primary flight controls on a 767 and how big those are, how much pressure you would need, you can kind of see why that 130 knots is a very important number. Because let's face it, if you're not at 130 knots, you start to drop below that. Now all of a sudden you don't have hydraulics. Now all of a sudden you can't fly. You get where I'm going. Bad things happen, right? With no manual reversion on this airplane, only being hydraulic driven for your flight controls, that's kind of an issue. So with that being said, let's go ahead and talk about some of the system stuff a little bit more in depth and have a little bit better of an overview when it comes to the system itself. So this is a very generic schematic of where your hydraulics go. We all know on this airplane there are 3 hydraulic systems. We call them left, center, and right. I know other airplanes call them 1, 2, and 3. I know that other airplanes call them the A and B systems. The 7.6, it is left, center, and right. So all of them have that particular name. That's how they're associated. Now, the question that always gets asked, whether it's by me, whether it's by other instructors, whether it's on an oral, what system is the heavy system? So I'm going to pause here for a couple seconds, and I'm going to let you look at this schematic, and I want you to think in your head, which one's the heavy system? Okay, so 1, 2, that's long enough. Alright, so it's the center. The center hydraulic system is the heavy system. Why is the center system the heavy system? That's the next question. It's always the next question. It's why? If it is the center system, why is it the heavy system? And it's 2 reasons. Kinda. It's 4 on this picture, but it's really 2 reasons. So I've got gear, so that includes my nose gear, my nose wheel steering, and I have flaps and slats. And I count flaps and slats as 1 because they all run off that same system. We'll talk about more about that when we do flight controls on a different video. So right now, nose gear, nose wheel steering, main gear, flaps and slats. Those are the 4 things that make this system heavy. There are other things that can be added to it that maybe not every airplane has, one being a hydraulic driven generator or an HDG. It's not in this schematic because not all airplanes have them. But if you have one that's installed on the center hydraulic system, that would be another reason as to why this is considered to be the heavy system. Okay, so What makes that important? It's because no other system has these things. So no other system has nose gear, nose wheel steering, main gear, flaps and slats. Okay, I can put my flaps down electrically. I can put my gear down electrically. I can't do it hydraulically without the center system. So the center system is the only one that has those, therefore they're heavy. Everything else, by looking at this schematic, you can see spoilers, for example. Spoilers are split amongst all three. Rudder, split amongst all three. Elevators, all three. Servos for the autopilot, all three. Even the ailerons. The ailerons are split, two systems each, and the systems aren't even the same. This stuff is what we'll talk more about in flight controls, but you can see just the hydraulics themselves give you a backup to be able to operate certain things, which is great because, as I mentioned on the last slide, there's no manual reversion on this airplane. So what does that mean? That means that there is hydraulic system, there's cables that go out to hydraulic servos. Those hydraulic servos are driven by the hydraulics, and that's what actually moves your flight controls. Okay? If I have no hydraulics, I have now broken that link between the mechanical, which is that cable coming into the servo, or the hydraulics for the servo. I said that wrong, didn't I? Yeah. Cables going into the servo, trying to actuate it, and with no hydraulics, there's nothing to move. There's no way to move that flight control. So, no hydraulics. What's that mean for you? It means you're a lawn dart, unfortunately. That's kind of what ends up happening. And I don't mean that in a bad way. Please don't take that as me saying anything bad about this airplane, because to do that, you would have to lose all three hydraulic systems. Statistically, very difficult to do. I'm not saying it can't be done, just saying statistically it's very difficult to do. Part of that is because of where your reservoirs are located. The right reservoir is located in the right pylon, left reservoir is in the left pylon, center reservoir is in a gear well. And off the top of my head, I can't remember which one. You can see it. It's a giant metal basketball looking thing that has a bunch of hydraulic lines running into it and running out of it. So you can kind of tell that that is your reservoir. But anyway, they're separated. They're all separated. So for there to be a complete loss of three hydraulic systems, something bad has probably happened to the airplane. But again, not saying it can happen. I'm just saying it's statistically unlikely that it would happen. You would lose all three. That's why, there's one hydraulic system loss in the QRH. It's a non-normal. Two hydraulic system loss in this airplane is an emergency, and three hydraulic system loss in this airplane is not good. And you wouldn't be able to recover from it. So anyway, just again, not to be a downer, I just want to explain it. So some other things that we can look at in this schematic to kind of maybe help solidify some of the things I've already said. And I do apologize if I'm talking quick. You can rewind the video or pause and then go back and look at the other stuff. So here, center system reservoir. I told you the rat is on the center system, so here's the rat. So if we follow the line here, fluid comes out, goes through the rat, comes through a check valve. It can't go through this check valve, so literally it's forced out this direction, so it can go to stabilizer trim, spoilers, rudder, elevator, autopilot servos, but if you're down to where you're running the rat, you're not going to have an autopilot. And then your left and right inboard ailerons. Okay, so you have one servo on each aileron on the inboard, 2 servos on the rudder, or elevator, excuse me, 1 servo on the rudder. Half of your spoilers are ran by the center system, but that's it. You get no flaps, slats, or gear, because that's all going to be ran electrically at that point. So, excuse me. Yeah, so that's what you have there. When we get into talking about landing gear in a future video, I'll explain a little bit more about what these isolation and supply valves are here. That deals with your landing gear. So we'll get into that during that discussion. Yeah. Then if we want to look here, so left engine pump, this is my engine driven pump, electric, and air. Now, this is where the nerd up here kind of comes out. This airplane is kind of cool because it can use pneumatics from the center pneumatic duct, and it can use that air to run through an air demand pump. That air demand pump can then run hydraulics, and then the hydraulics can then run everything else. If this airplane was equipped with an HDG, or hydraulic driven generator, there is a potential that we would use pneumatic air from the center duct to run the air demand pump, or the ADP, and turn that pneumatic air into hydraulic pressure, and then turn that hydraulic pressure into electricity. That's just freaking cool. I mean, that's just cool. And if you want more about that, tell me. I can make a video on how that works and how the HDG works and all that kind of stuff. I talk about it a little bit in the electrics video, but I can make one specifically on the HDG, and that's just kind of cool how that can work. But now that I'll take the nerd hat off and put my instructor hat back on, I have electric demand, electric primary, electric demand, engine driven primary, pneumatic demand. Okay. Alright, so I told you there was going to be some differences between the pressure lights. So the first thing we'll talk about is what's the difference between a primary pump and a demand pump. Now, the primary pumps are primary, right? So that means they have to run all the time when they're turned on. So if I turn on primary pumps, they're running as long as there's power available to make them run. The demand pumps, on the other hand, don't work that way. The demand pumps only run when they're needed, if they're in the auto position. If I have them turned on, then yes, they're just like a primary. They turn on, they run. But if I have them in the auto position, the only times my demand pumps are going to run is high system pressure demand. So like high system pressure demand, so high demand. Or low system pressure. If the system itself has low pressure with the primaries running, the demands will kick on and run to help supplement. If something kicks on that causes the pumps to go from a normal pressure to a low pressure, which would be a high demand item, such as gear, flaps, and slats, then your demands automatically kick on to run those. So for example, on the center hydraulic system, I've said that it has gear, flaps, slats. Okay? So that means anytime I move that handle, if I move that handle up, I move that handle down, I move the flaps out, or extend them, or I retract them. Anytime I move that handle, anytime it comes out of the detent, boom, that ADP turns on, or that air-driven pump turns on and supplements that pressure, because it knows those are high demand items because they need a lot of pressure to be able to move them. Which is why when you move them electrically, they move so much slower, because they don't have that additional pressure. Okay? Now, one thing I didn't mention, what is the pressure requirement for the 7.6? There isn't one. And I say that jokingly because we don't make students memorize the pressure that the system has to have. Hell, there are airplanes that have been ordered that on their status page don't have the pressure on their status page. So there's no way for you to check it to know if the pressure's high enough. All you get are pressure lights. That's how you know the system pressure is either too low. is the fact that there's system pressure lights. Outside of that, you're not required to know that. However, Boeing is Boeing, and it's about 3,000 psi is the normal, if you care to know. That's kind of gee whiz information, but if you care to know, 3,000 psi is what it is. There is a plus or minus. I think it's 200 or 250. One of the two is what's stuck in my head. So it's somewhere in that regard. You could probably find it if you dug around in a maintenance manual, but in an ops manual, you're not going to find it. Alright, so now you know the difference between the pressure, or the primary and the demand pumps themselves. What about the pressure lights? So, I'll give you a second to think about this too. Why would there be a difference in the pressure lights of the primary and demands? And when I say that, I mean as far as when they turn on. Okay? So, the reasons behind the pressure lights illuminating are different between the primary and the demands. So just think about that for a couple seconds. Okay, so now, the reason for this, the primary pump's purpose of the primary pump is to run and to give me pressure. That's what it's there for. Whether I need the pressure or not, it runs and gives me the pressure. Therefore, if it doesn't run, or it's not giving me the correct amount of pressure, I get a pressure light saying, hey, look at me, there's something wrong, I'm not giving you what I should. Demands. It's not always the case, right? So for the demands, they may or may not run if they're in the auto position. So what's that mean? The pressure light only comes on when pressure is requested from the demand pump and not given. So it's a pressure requested, not given light versus a low pressure light. And I say that in a way meaning the demands, if they're not running, I don't get a pressure light because they're not running. Okay? Because it's normal for them not to run if the primaries are holding the correct amount of pressure. If I request them to run and they don't run, that's when I get a pressure light. Or if I don't get the correct amount of pressure out of them when I ask them to run, they turn on and all of a sudden I have low pressure out of them, that's when I get a pressure light on the demands. So it's pressure requested, not given. Okay? Pressure requested, not given. So that's the difference between the pressure lights on here. Now, let's talk about some quirks. I think that's how you spell quirks. Let's talk about some weird stuff that demand pumps do. First one we'll talk about is the right demand pump. Okay? So the right demand pump does this crazy thing where it runs constantly. When in the auto position, it'll run constantly if I do a certain thing. That certain thing is when I put my flaps in a takeoff setting. So flaps in a takeoff setting for the 200, that's 1, 5, 15, 20. For the 300, it's 5, 10, 5, 15, 20. Because I can't take off the flaps 1 and a 300. So what's that mean? Well, on the right side, in case you were or weren't paying attention to this, your normal brakes are on the right hand side. Okay, so if we look at that schematic again, the right hand side is going to show normal brakes. Center system has alternate brakes. Again, we'll talk more about that in depth when we talk about landing gear. But for now, just know, right system, normal brakes. Okay, so what do I need, or what does normal brakes give me, or why do I have to have normal brakes? Part of that is because I need rejected takeoff for every takeoff. So when I pull the airplane out onto the runway and I'm getting ready to take off, my RTO switch or my rejected takeoff switch needs to be in RTO. Okay, so why is that important? RTO is part of my auto brake system. My auto brake system only runs on normal brakes. My normal brakes are only on the right hydraulic system. See where I'm going? So the worst possible position that the airplane could be in for me to find out that my right demand pump didn't pick up is when I have a right hydraulic system failure in conjunction with a need to reject the takeoff. That would be awful, because if I get into that situation, all of a sudden the demand pump goes, oh no, I'm not going to work. Now I don't have my RTO, so I need to know that I need to get on the brakes. So when the airplane is on the ground, meaning the main trucks are untilted, saying the airplane's on the ground, and I put flaps into the 1, 5, 15, or 20 setting. Now here's the thing, 300s, the takeoff setting is 5, 15, or 20. The pump's still going to run at flaps 1. Okay? Flap will still run, or the pump will still run at flaps 1. You just can't take off at flaps 1 in a 300. So I just want to make that clear. But I put my flaps out. What happens? My demand pump turns on and starts to run. If it doesn't run, or it doesn't give me the pressure, I get a pressure light on that demand pump telling me that I don't have the pressure in case I would have a reject and I didn't have right primary pump working for whatever reason. Whether it's an engine failure, whether it's a whatever, whether it's a complete pump failure during takeoff. Having that pressure light show up as early as possible gives me the opportunity to not put myself in a bad situation, right? So that's one of the reasons why they do it. Alright, next thing. We'll talk about the left demand pump now. So the left demand pump, this one's not near as convoluted, it's not near as confusing. The left pump just doesn't run, or it's inhibited to run until I get a second generator that comes online. So if I'm running the APU, that's one generator, and then I start an engine, that's 2 generators. All of a sudden my left demand pump will run if needed. Or, if I have, both engine generators running, it'll run. If I got the ground power car and an engine running, then the left demand pump will run. It's just as long as I'm not on single generator operations, right? And that's to help with load shedding, essentially. Alright, so the other big thing here is going to be how we pressurize the airplane. So a lot of people look at this panel and they just say, well, I just turn all the pumps on and I'm pressurized. That's very true, you would be. However, it's against almost every manual I've ever seen for the 7.6, but you would be pressurized. You absolutely would be. So, how do we pressurize? It's easy. We go from the right demand, because our engines are already going to be on. So our left engine's already on, our right engine's already on as far as the pump's concerned, but they're not going to run because the engine's not running. So therefore they can be on. It's not a big deal. Alright, so we go from there, we go to our center primary pumps, we go number 2, then number 1, and then we come down here to the left electric, go to auto, and then go to the center pneumatic, the ADP, and we go to auto. Okay. Now, I did really good on how to pressurize this. Now, how do I depressurize it? That's one thing I actually did not put on here. So, depressurizing, the exact opposite. So I go center to off, or center demand to off, left demand to off, hydraulic 1 off, hydraulic 2 off, and then right demand to off. That's how I depressurize. Now, people might look at that and be like, man, that's weird. Why would I do that? I just have the switches here. I'll just hit the switches. Again, that will work. However, there is a shuttle valve that's in the landing gear that if you turn these switches on in the wrong order, you can actually move that shuttle valve one direction or the other, and it causes fluid to move from one system to another. Now, that doesn't seem like a bad thing, and it's not 99% of the time. That 1%, however, you could have contaminated fluid, you could move it over, and now all of a sudden one of your systems is low, and you have to have it serviced anyway. I mean, there's other complications that come along with it. So, the SOPs most of the time, check with your airline, check with your operating procedures, all that kind of stuff. They're going to say to do it this way. So you go, right demand, you go counterclockwise to pressurize, clockwise to depressurize. Now, the other thing that kind of gets people screwed around is there is a note that gets put into the manuals most of the time. Again, I've worked for 2 airlines now that teach in the 7.6. They both have the exact same note that talks about this pressure light right here on the number 2 electric. Okay, so I turn this switch on, or go to auto. I go on, auto, auto. I have to check and make sure that this pressure light illuminates. That again is another type of load shed thing that helps protect the electrical system and allows the electrics to go where it needs to go to provide the electrics where it needs to be provided. Okay, so again, that's kind of a quick and dirty on the hydraulic system. There's a lot of stuff that I didn't talk about that we could talk about later in other videos. That is just the hydraulic system in a nutshell. Okay, so again, all I can do is ask you to do what I ask you to do at the end of every video. Subscribe, hit the notification bell, like it, share it, let other people know where you find this information, because I love teaching. I want to help as many people as I can. With that being said, in the description of this video there is a link to a Google Doc for this PowerPoint. Okay, so if you don't want to listen to me drone on for, I don't know, however long I've been talking, you can download the PowerPoint to this and you can just look at it. It has notes in it. They're kind of longer notes for that purpose, so you can look at those. It's 100% free. I don't charge for it. Again, I like doing this kind of thing, so you can download it, share it, whatever you want to do. Okay. For the IRS one, that was the previous video to this one, there's a handout for the IRS that I put together. You can like it, not like it. It doesn't affect me, really. But if you like it and you want to share it, great. Same thing with this one. If you like it and you want to share it, great. That's awesome. The link will be in the description. However, with that being said, everything I do is free. I am going to put a link down there to a Venmo, that if you feel that what I give is worth it and you want to donate, or you want to whatever, you want to send me money, you don't have to. I'm just saying that it's there if you want to. Then please, by all means, send it to the Venmo. That allows me to do a few things. It allows me to continue doing this type of work, in addition to actually contract instructing with other airlines. Because honestly, if I wasn't able to do that, I'd end up having to take a job probably in scheduling, and nobody wants to do that to me. Please. But anyway, so that link will be down there too. There's also links to the Facebook page, I think Patreon, but right now I don't have anything to Patreon, so it's kind of a moot point. You don't really need to do anything with it just yet. But yeah, it's all in the description. Check it out. Download what you want to. Outside of that, I hope you guys enjoyed it. I hope you got some good information out of it. Hope maybe it made you think of some questions. And if you thought of some questions, go ahead and comment, send me an email, whatever. If you're somebody I've taught or somebody that knows me and you have my phone number, text me. I'm always happy to answer questions about aircraft systems. Outside of that, the next one, I'm hoping about every other day is what I'm going to be shooting for these videos. But we'll see how it goes. Right now I'm going to post this one, and then I'm hoping in 2 days time I'll have another one for you. And we're just going to do it until I cover the entire overhead panel. So yeah, next thing I'm going to show with this is I am going to put a short video up about how to pressurize, and I'm actually going to be in the X-plane airplane. I'll show how to pressurize and depressurize and how to flip the switches. But outside of that, I hope you guys have a great night, great day, great morning, whatever it is for you. And we'll talk to you on the next one. See ya.